And we're going to start talking about experience and sharing experience about multi-vendor support when we deploy the Crosswork Network Controller and across a lot of vendors and a lot of customers. I'm happy to present you with Jill, coming from our CX organization, who's going to share their experience. Thank you, Jill. Take it on.
Thank you. Okay, hello everyone. My name is Jill Arumi. I'm a solutions development architect from the CX EMEA service provider team. I'm here with my invisible partner, Nicola Martino, TME, who unfortunately couldn't make it due to some last-minute emergency. But I will be presenting his part and then my part more on the CX real cases. And there's some couple of demos that Nicola was able to record with audio included, so I will be playing those in the middle of the presentation. All right, so let's start. So in this session, we will be talking about the CNC EMF, the element management functions that were already introduced by some of the colleagues from Cisco before. But we will delve into what it takes to make it support multi-vendor device, third-party device types other than Cisco, and what comes out of the box, what needs customizations, and the different types of customizations, what can be done, what has been done already in several projects, and what is coming up next. So, as I said, I will be introducing very quickly on the CNC EMF, the element management functions, and then we will talk about the out-of-the-box coverage and what are the different customization options that we have. And finally, we'll look at some real project where Cisco CX have implemented this. So the element management functions on CNC, it's something that was started some releases ago. We started porting some of these element management functions or functionalities from EPNM onto CNC. It's almost everything there, not fully, but almost. So it's a great way to manage your access with the essentials tier license, and you can have a good monitoring and visualization of all your multi-vendor network. We will see in more detail the inventory, alarms, performance management. Actually, in these slides, you can see the different components of element management functions. Starting from the top left, we have the device inventory from after you onboard the devices, perhaps using zero-touch provisioning. You put a day zero config. Then you can discover and visualize the inventory and also the full network topology. Next is the device fault management. So we collect all these events, these log messages from the network. Some of them get translated into alarms that are visualized and managed on EMF. Then we have device performance management, where we collect these different KPIs and metrics at different levels, device, link, interface. And we can also program some alarms, some threshold crossing alarms, and see the historical graphs. I think you've seen some of these already before, today and yesterday. And finally, the device image and config management. We have the SWIM, the image management capabilities, and also now in the latest release, we have configuration, backup, and restore, among others. Okay, so in the next few slides, I will very quickly just show some screenshots of the different EMF functions for you to have a high-level overview understanding, especially if you are new to CNC and to EMF. And then we'll talk more on the multi-vendor and customizations. Okay. So deep inventory here is where we do a discovery via SNMP of the different device inventory, and we show them on different views from the topology map on the device list we see all the product names, product IDs, serial numbers, and some nice graphs showing how it all links together. Of course, the inventory gets automatically updated when there are changes in the network. It's all real-time updated. Next is the device alarms. As I was mentioning before, we collect events and messages via SNMP or syslog, but some of them get converted to alarms that you can visualize, you can manage, you can see or sort them by severity, you can clear them, add nodes, show a summary in the topology map, so it's very customizable. And okay, I think I had it another slide about what goes into the alarms and what doesn't. I will show it later on. Performance monitoring, here is where we collect performance metrics via different protocols, and we show them at the device level or link or interface, and we have this nice historical graph where you can see how all these different KPIs have been evolving over time. Then in the 7.1, we now have the underlying configuration, config templates, where you can provision the devices, not via NSO, but directly into the device based on templates that you can have. There's a deployment wizard, some backup and rollback options. So it's very simple now to implement simple changes across all the network devices. Next is also a new feature on 7.1, configuration management and backup and restore. We can program manual, or we can do manual and periodic backups and restore them. We can also do some side-by-side comparisons of configurations over time. All this was, comes from EPNM, so we've been porting all these into CNC over time. The next one is the SWIM, the software image management, where we have the full life cycle of all these images, from selecting the image, then selecting which devices you want to check or to deploy, doing the several deployment options, and finally doing the validation and the deployment of the software into the devices. Going very quickly because this is just an overview. The next one is the zero-touch provisioning. We have different flavors, from the classic ZTP that is only supported with Cisco XR devices. The secure ZTP is for XR and any third-party device types, and the plug-and-play ZTP for XE only. Okay, here I'm just showing a page on Cisco and CCO page where you can check exactly the support for each model in Cisco devices, where it shows exactly what is supported on all of these EMF functions for every device model. We will now talk about the third parties. So for other third parties, a lot of it can be supported, but via some customizations or out of the box. So that's obviously not documented in this document, this page. Right. So here's where we start talking about the out of the box support for multi-vendor, for third parties. As you have heard multiple times already today, the CNC has been designed from the ground to be a vendor agnostic platform. It supports pretty much any device, any transport, IP transport device that supports some standards-based protocols and interfaces. So that being said, still until now, when we need to certify or make all these validated and tested for specific customer and specific third-party vendors, typically Cisco CX, which is the team I'm from, we need to get engaged to perform some interop testing or validation, and then we will see in many cases we need to do some a bit of customization and development to make it all work. When the third-party devices support some open standard MIPS, like SNMP MIPS or open config data models, then CNC EMF will provide some support directly out of the box without needing to do anything. In areas like inventory, topology, fault management, or performance monitoring. For inventory, the discovery process relies in SNMP. In the roadmap, we will support other protocols like GNMI, but for now, it's all based on SNMP. We use these three MIPS. The one in the middle, entity MIP, it's a key one, but unfortunately, almost only Cisco provides a full implementation of this MIP. Most of the other vendors either don't implement that MIP or not the way that CNC expects. And this is one of the areas where we need to add some custom device packages to make this full discovery work from the Crosswork Data Gateway, collecting SNMP data and then making it understood by CNC and by the inventory application. Okay. Then in terms of alarms, we collect all these SNMP traps and syslogs from CDG. Some of them will be converted to alarms. At the moment, for third parties, it's mainly traps and also syslogs. This is not fully updated. In release 7.1, we can customize both traps and syslog messages that come from Cisco or non-Cisco devices. And I will show in a demo how this can be customized and converted to alarms. Because not all the events, all the traps or syslog messages end up as alarms. There is an internal alarm catalog within CNC that only those events and messages that match in that catalog get converted to alarms that can be visualized and managed from CNC. The rest will remain as events in a separate event list that is also kept and logged, but only the alarms are really manageable lifecycle and also exported via kind of the EMF northbound interfaces, APIs, or Kafka as alarms, not as the CDG allows to export all these raw events and messages and at the CDG level as well via Kafka. But here we are talking about the EMF application that normalizes and models everything independent of the vendor in a normalized way, towards the upstream. In terms of topology, the discovery of layer 2 relies on LLDP MIPS and the lag MIPS. Again, not all the vendors support these MIPS or in a standard or in the same way. So we have sometimes struggling with this on some vendors. I will show you some examples at the end. And for layer 3, we normally rely on BGP link state protocol to discover the layer 3 protocol from IGP, and for that we need the SRPC in the solution, right? That as part of the CNC, which is in many cases there from the beginning. Then we have the performance monitoring. Here it's a mix of different protocols, SNMP, CLI, GNMI. You can see that for Cisco we use some MIPS and some protocols. For third parties we use others, SNMP v2 and OpenConfig for device level KPIs, and if MIP for the interface health. And again, here sometimes we need to customize things or to adapt if needed. Right, so I've talked a lot about customization options or need. So basically, in release 7.0, that's where we started to formally allow to implement some of these customizations, starting with the CDG device packages that are a key part of these adaptations for multi-vendor, as well as some device performance monitoring or management extensions within the technologies that are already supported in 7.0. But in 7.1, we are expanding that to a lot more things, like the custom traps and syslocks that I mentioned before. You can now pretty much any trap or syslog message you can program it to be converted and managed as alarms. We can also customize the performance management metrics for also new technology support. And we have the new features as well, the backup and restore and config templates that also allow customization for multi-vendor, which we will see also in the demos. Okay. We have this table summarizes what if we look at starting from the right column, you can see that many of these customization options rely on some internal frameworks. That means that the framework that is needed to customize or develop some of these device packages and others are at the moment internal within Cisco, and only Cisco BU or Cisco CX can implement those customizations. Also, well, it requires some Java skills, but that's not a problem for partners or customers. So at the moment, only the custom and faults and syslog messages can be customized by the end users or customers. The rest require help from CX. On the custom faults, there is the specific API calls. As you can see, the custom syslog, custom traps. We'll see in the demo how to use them to easily make a syslog message be converted to an alarm. But that's, for now, it's the only part that can be done by the end user of EMF. And I think that's the first part of the slide. Now we will see a couple of demos that fortunately Nicola was able to record before he had to leave. So it has audio as well. So I will just play the demos and we will hear how Nicola is demoing both the multi-vendor, it's a Juniper in this case, configuration, provisioning, and also the fault, the syslog to alarm conversion. So let's see if this works, because it's embedded in here. I think I need to click once more.
In this first part of the demo, we will have a look on the out-of-the-box capability of CNC managing, this case, Juniper virtual devices. So I have a couple of VMX, Juniper VMX, that are shown here on the map. So we see that those are connected by a couple of links. We click on the link, we see this is an LDP link. We can see the interface determined the link, some counters like utilization drops. Those are current counters. We also have an history tab that shows the same counters over time with drops, utilization, and errors, and so on. Now, if we further the down at the device level, we select this device here. We see generic informations. We see that the product type is generic and reports the sysobject ID. Links automatically discovered. Also interfaces automatically discovered by means of ifmap. The inventory is currently empty. This can be either the entity maybe is not returning any data, but in this case, those are Juniper devices, and there will be in any case no data. Now, I will simulate an alarm. I will shut down one of the device interfaces. This will generate an alarm. That alarm will be coming from a standard MIP. So in this case, being a standard MIP, the system will be able to detect the alarm and show in the alarm list. Pretty fast. We see the alarm here, it's a link down. Same if we look at the device alarm list. The alarm list, we have this Juniper link down alarm. If we rather look at the event list and filter by the Junos, we see that we see not only the alarm, this 10 gig here, but we see also a lot of generic events. So those ones that don't match and enter in the catalog won't be discarded, but will be listed in the event list. For example, we see that one of those will be the syslog that gives information on who does what on the system, the configuration that I've done to shut down the interface. Now I'll use the customization option introduced in Save 1 to show you how to customize the system and translate this generic event, this syslog, in a proper CNC alarm. For this customization, we will use CNC API and Postman as a client. So the syslog will be pretty much what you see here. So this is the syslog, let's say, category, and then followed by the username, and then what was done on the interface. We have a dedicated API call that requires a payload that checks for the syslog string to contain this category, and then it also parses the username with this regex, and we generate in this case, critical alarm with this description. So user username made a config change. Now I will push down this call, succeed, and now let's test it again. Okay, we are back in the device alarm list. I will simulate again an admin down. Okay, let's see. Refresh. Okay, indeed we have the link down alarm as done before, but together with the existing alarm, now we have also a new alarm. You see, user Nicola made a config change. So this is exactly what we have done. That's it. The second part of this demo will focus on configuration backup restore and templates on the Juniper VMX. So for this target, we will use a custom package that we will upload to the system. Before we upload that file, we need to change a configuration file that basically adds support to this specific sysobject ID, if you remember from the first part of the demo, where we also set sysname, OS type, family, and other details. To upload the custom package, we go to the data collector global settings page. We have one option for custom packages. We add a new package, select aggregate package. We use the browser to upload this specific Juniper config custom package. We click upload, and now that the package has been uploaded, we need to onboard again the two devices to take effects. Now that we have added again the two routers in the system after the device configuration change, we see now that the devices are populated with proper type, family, and series. Now, if we check on the backup and restore, we should also see the two Juniper devices here with the backup file backuped. The device automatically onboards the configuration, the running configuration once we onboard the device, and indeed, this is the device configuration that has been backup. And now we'll see the templates. we see that we have a template for already created for changing the interface description on the Juniper VMX. Let's deploy. We select our Junos 49. Next. Interface has been already populated, but we can eventually change it. Let's give it the description. I don't know, demo 1. Next. This is the command that will be sent down to the device. Now deploy. Okay, now let's go to the job page. Let's refresh. Okay, it's in progress. Succeed. Now switch back to CLI. This is the configuration description before the template. Now let's run the same command again, show configuration interface, and you see here now the description has been changed.
Audio? Hello, yes. Great, so apologies again for Nicola not being here, not being able to be here and presenting the demo in real life, real time. But I hope it was interesting enough, or you could see the same this way. Now we'll be transitioning to the last part of the presentation. This is the part that I prepared myself as Cisco CX summary of some of the initial projects that we are doing for service providers in EMEA and globally on customizing CNC for multi-vendor. I must say that we are starting many additional and very big projects this year where we will be again or even customizing or deploying multi-vendor and adding some other customizations for other customers and other device types. But here I will cover 3 of the main projects that we've done so far in the region. Before I do that, I will quickly go through this summary table where you can see what are the different use cases that can be customized in CNC and at what level or object and what is the actual customization. I think before, I forgot, Krishna or someone else already touched on some of these. So provisioning, you all know that the NSO, the transport SDN core function packs can be customized for specific VPN requirements or service types based on L2, L3 NMs, but also the RSVPTE, the SRTE packages that come out of the box do need to be customized, or all of them need to be customized for third-party devices. And when you do customization of the TSDN, then you also need to customize the active topology. The CAT needs to be customized so that the service and the underlying transport can be properly discovered and visualized on the map. Then we have the EMF inventory performance alarms. Inventory and performance require, or the customization is based on CDG device packages to collect third-party inventory via SNMP or collect PM metrics via SNMP, CLI, and OpenConfig. And the alarms, as we've seen before, you can customize them for any syslog or SNMP trap to be seen as an alarm. We have also seen in previous presentations the service health, service assurance for multi-vendor, for third parties. You have to customize the heuristic package to support the specific paths and metrics for that device type. But we have a good baseline, and we've started to do this for some customers already. On optimization engine, traffic statistics, sometimes we also need to build some device packs to collect properly the statistics when there is no good support from the device, and sometimes we need to do some like this traffic delay mapper to get things like delay that is not advertised via IGP. Then we have the ZTP, the secure ZTP for third-party support. We can customize the ZTP scripts, the configuration templates. And finally, if you are using the embedded workflow engine within CNC, then obviously you can configure, you can customize the, for example, the fleet upgrade. You will typically build custom mobs, maybe even add some activities, and customize the mob for each specific device type that you need to upgrade. So that's the summary table, and now we will see three real examples of, again, only very high level, because I only have a few minutes left. The first one, okay, there's a lot of text. I will just summarize it for you. The first four lines is where we have customized the service model, service provisioning for L2, L3, VPN, and traffic engineering for Cisco and for Nokia network elements in this project. So nothing too new. We also built an SNMP collector to collect TWAMP delay measurements from Nokia devices that were lacking the support of that delay into the IGP. So we had to collect it specifically. Also for the same legacy or old Nokia 7210s, we had to develop some PCEP adapters because those models do not support PCEP protocol. So we had to build a very creative NSO package to be between the SRPC and CNC and the Nokia box and be able to provision the RSVPT tunnels. We also developed a use case for what's called low latency bandwidth aware admission control, where we use some capabilities within CNC, like change automation, service plays, and the COE OPM modules to also be able to create and find these low congestion paths end to end and be able to provision this nicely on the network. And finally, it's still a work in progress, but we have started to build some device packages for the inventory, deep inventory for Nokia, Juniper, and Huawei. Also some device packs for topology to fix some of the issues we found with Huawei on LLDP and Juniper and Nokia for lag. So we will be fixing those via device packs. For service health, we will be customizing the heuristic packages, again, for those three third-party device types as well for this project. That was the first example. Okay, here I'm just showing that PCEP adapter that we built on NSO, where you see that it's using both RSVPT provisioning package and a PCEP adapter that talks to the SRPC and to CNC to emulate what the head end should be doing on itself, as you can see on the Cisco site. So that was a creative piece of work from my colleagues that solved the problem. The second example is another global service provider where we did a lot of customizations both at NSO and CNC levels. At NSO, we started building some custom open config nets for you see the third parties are Juniper, Huawei, Nokia, ADVA. This was later changed more to the native models, but initially it was all based on open config, so we had to do a lot of work there. We also did some service provisioning models, layer 2, layer 3, VPNs for this third-party device. We enriched the CNC topology, creating some custom inventory and aggregating data from sources, including CNC itself, but also NSO, CDB, and devices via netconf. And finally, we developed a Huawei device onboarding tool that will validate the configurations and will facilitate the onboarding of many, many devices in a short time frame. That was on NSO. On CNC, we've developed a device pack to help compute or get the MPLS interface traffic to get the proper traffic values on the CNC topology. And we are implementing some deep inventory customization to be able to correctly get all the inventory data and integrate it northbound with our HCO. Finally, the third SP real use case is another SP where we integrated Huawei routers for inventory up to the HCO again with a CNC adapter. Here we had to develop several device packages that were collecting the inventory data from the Huawei nodes and reformatting that towards the CNC application. Here, maybe I can show a bit more detail. The CDG device packages using this XDE PAL framework, this internal framework that I mentioned before, are collecting via SNMP things like hardware, software, interface, configurations, and operational status. And then that data is abstracted and normalized by this XDE PAL package, and it creates a uniform format that is what can be consumed by the EMF application and also CDG. So that's what we did for this third SP. And I believe that's the last slide. So thank you very much for your attention. And if there are any questions, I'll be happy to.
Good job, Jill. Thank you for showing us reality.
Yeah,
you know,
sometimes it's needed.
Yeah, sometimes reality needs adapters, correct? And you know, also reality that our customer lives is that, you know, we got, sometimes I call it that we need to do archaeology, correct? Looking at very old releases, very old technologies, and adapting that, massage it in a way that can be transformed to work with modern tools. So let's look at the questions. We got one that is very interesting. So they're asking us if there's any support for device and network topology discovery for legacy devices, archaeology again, that don't support the LLDP or lag MIB and instead use custom or proprietary MIBs.
For layer 2, I guess, right? The layer 2 topology.
Maybe the first thing we can say is that from a topology perspective, there is the layer 2 topology and the layer 3. Both of them are supported in Crosswork for visualization. So for layer 2, it allows us to, you may have a layer 3 link, but actually multiple lag or aggregation path between the two, correct? Now, I guess you can also, just like we do in topology, the question is, can we create a custom package that actually help us with the layer 2 topology?
Yeah, I believe we can. I mean, this device pack seems magical, right? You can do almost everything with them. So I believe we can, create a device pack that will use these proprietary MIPS and do a lot of conversion into what the CNC topology layer 2 expects. Also, I remember Sasha from Telecom Serbia explained how they did, with NSO in that case, but they discovered that layer 2 topology looking at the ARP tables and MAC addresses. So I guess things, creative things can be done at that level as well.
Fantastic. Yeah. So the answer is yes, we should be able to do that with device package. Please contact us to help you. But I think that's great. That's part of the flexibility, correct? We need to take that archaeology and bring it into a topology. All right, I think we are done. Is there any question? You got the Slido? Anybody from the audience? Okay.
Thank you very much.
Jill, thank you very much.
Yeah.